Now, yesterday, we discussed circuit analysis. I'm sure you must have understood that. I'll give you a question. The question, you will find such questions coming in your NTC exam. Now, when an examiner sets a paper, what would his intent be? Everybody can solve it. But then, that question should provoke you to solve, but ultimately, there should be certain students who can solve it. Now, this question is in that category. This looks a very simple question. Have a look at it. A very simple question. I'm giving all the resistances as R. Now, my question is, or the question to you is, what is the equivalent resistance between A and B? Equivalent. Let's see, what are your options? What is the most probable answer you feel this question should have? R by 2. Perfect? Incorrect. You get only one option. Now, some of you say it is R by 2. It looks as if it is R by 2. But then tell me one thing. When I say calculate equivalent resistance between A and B, okay, I'll modify this question for you. Now what? Zero. You say 0. Incorrect. It cannot be 0. Okay, now let me do some redrawing. Both are grounded. Can I ground them together? Can I do that? Can I do that? Now, when I say find the equivalent resistance between A and B, what I mean is that if I could place a battery, say of potential difference V, right? The amount of current drawn from this battery and the resistance between these two terminals, or the current which flows from this battery, V divided by this current should give me equivalent resistance. Do you agree? Now, can you tell me what current it is drawing? Can you find out? Now, yesterday we discussed nodal analysis. I told you in nodal analysis that we can actually replace this battery. Right? Now, can I take this as V and this as 0? Can I do that? I cannot. Because this is already ground. So this is, please understand, in a battery, when you say V and 0, you can only do that if there is no other point which already has a 0 potential. You cannot have two references. You can only have one reference. And by default, this has to be 0 because this is grounded. Now, if this is 0, right, that means this is also 0 volts. Now, I don't know the current which is flowing from here. So I'll assume this to be X volts. Yes or no? Now, मैंने यहाँ एक battery लगाया. I had put a battery. Now, when I move from X to this place, this potential difference is V. What will be the potential of this point? Will it be X plus V, X minus V? No. When you move from a lower potential to a higher potential, you add something, right? So if this is X, this is going to be X plus V. So I can replace this and call it X plus V. Do you agree? And what is the potential of this point? Perfectly fine. Now, I told you yesterday how to use the method of nodal analysis. Let me select this as my node. What will be your equation? Hold on. X below minus 0 upon, very good, plus ये x है, this also x. क्या लिखूंगा? x minus x minus v by r. You agree? Same thing will go for this also. So I can put it right, and this should be equal to, what is the value of x? Find out. X is, that means the potential of this point is, and of this point is, write this down. Understood? वो भी clear हो गया. If this is 2 volts, I added V, it became 3 volt. And the potential difference still is V. Right. Perfect. Now, after you do this, this is 3 volts, and this is 2 volts. Now, this, and I want to find the value of R equivalent. What is R equivalent? V by I, right? Now, let me see the potential difference. ये कितना है? 3V minus 0 upon plus, there are three directions in which the current is flowing. You agree? ये कितना हो जाएगा? 3V minus effect into 2. Yes or no? ये क्या निकाला मैंने? Current. And what is the potential difference? What is the value? What is the answer? Clear हुआ? Getting my point? The potential difference is V, and there are 3 directions in which the current will flow. One R. What is the value? What is the answer? Fantastic. And you thought the answer was that, right? You thought the answer was, this is what we have to understand. Don't go on the face value. Do not go on the face value of the question. Assess it properly. In the entire examination, out of how many questions do you get in IIT in physics? Circuits का एक ही question है. You cannot do a mistake. You cannot do a mistake because that is going to be the most crucial. उस जो आपने 1.5 महीना पढ़ाई करी सर्किट्स का, एक सवाल आएगा, mistake नहीं हो सकती. Perfect? That's fine. Number 2. Now, since I discussed nodal analysis and I assumed that most of the students were solving these questions, how did you find this method, the nodal method, in comparison with Kirchhoff's law? Simpler. So, अब मैं कुछ questions आपको कराता हूँ capacitors. Can I have the slide, please? Yes. I want to try this question. Let's do one more question on circuits. This problem has come up in I2J. This is 3 volts. This is 2 volts. This is 1 volt. Resistances are 1 ohm or 3 are same. And he says, what is the potential difference between these two? Right? And also, what is the current which is flowing in this circuit? Please try. I want you to use nodal analysis. Now, you would wonder that why this R has been given to you. That is for the second part. You get my point? So the first part is without the R. How do you solve it? Now, in the nodal analysis method I told you yesterday, you can have one junction to have a zero potential. That is called a reference node. You can assume one point to have a zero potential. आप मुझे बताओ, आपको नहीं लगता कि ये point, ये सब zero potential? What will be the potential of this point? Good. ये कितना होगा? ये कितना होगा? Now, I want the potential of this point. It is not known to me, so what can I take as that? एक zero ले सकते हैं. A known potential could be 0, and unknown potential would be x. Now, in the next 30 seconds, you'll be able to solve it. This becomes your node. What is your node equation? Start. X minus 3 upon 1 plus x minus 2 by plus equals x कितना है? X is 2. If you were to use your original methods, which are generally given in books, you would have used Kirchhoff's law. I1 idhar, I2 idhar. Then you make an equation for I1, you make an equation for I2. Then you solve it, then you get the answer. How much time did it take you? 30 seconds. Understand that you get 3 minutes to solve a problem in jail. It's not important that you solve it. The important thing is you solve it within 2 minutes. So you have to develop, or you have to make yourself capable in a way that every question which comes in IDJ, you solve it within 2 minutes. I'll give you those shortcuts, those techniques, those methods, which will help you. Like one of them is this. Clear? Now, suppose he says find the current in each element. Nikal gaya na? How much current is this element? X is 2V. This is, so if I were to write this, this will be 3V minus 2V by, what will be the current in this element? This is how much? 2V. So there will be no current which will be flowing in this. If I want to find current here, this is 2 volts, this is 1 volt, 1 ampere current. Also, if he says find the, if he says find the potential difference, tell me what is the potential difference between these two terminals. Iska voltage kitna hai? Khatam. Over and out. Finished. Acha. Now suppose I say, suppose in this question he hasn't asked. Suppose he says find the equivalent resistance between these three. Can you find out? Karna? क्या करेंगे? क्या लिखेंगे? R equivalent will be, what is the potential difference? 2 volts. And what is the current which is entering? ये opposite direction जा रहा है, so this will be V by 1. ठीक, तो माइनस लेंगे उसको. ये कितना? 0. परफेक्ट. ये कितना? कितना? Are you understanding what I'm saying? That is why he hasn't asked this. This R is coming to the R kitna, which becomes 0. R becomes, that is why he hasn't asked this. Fine. Are you getting my point? Next slide. Now, this again is a very peculiar type of a question. Have a look at it. Volts, 10 ohms, 2 ohms, 5 ohms, 10 ohms. He says, what is the current which is flowing through the 2 ohm resistor? Now, also understand one thing. Why do you think IIT exam gives you choices? Do they want that you should solve the question and then match? Sometimes you can just see the question and decide the answer. Like in this question. Tell me one thing. मान लेते हैं, assume कर लेते हैं. Can I come here? That the current starts from here, goes out. वापस आ रहा है क्या? If the current goes from this element, the current has to come back also. Current in a circuit has to follow closed path. It is not possible that the current comes out from here and also enters from here. Is it possible? It's not possible. It has to have a closed loop. It cannot go and come from the same point. Yes or no? And वैसे भी in steady state, you know that the net current of any node, any junction is, answer कितना होगा? Over. That means ये current यहाँ घूमता रहेगा. And this current will keep moving. You get my point? Therefore, the current in this 2 ohm resistor will be 0. Note karo usko. Now, when you note the answer, note the thought, not the solution. When you write the explanation and not the answer. The answer is that any node should have at any node, the net current should be 0. One. Number 2, if current leaves from one path, it has to come back from the second path. Now, there is only one path. That means current cannot go and come back. That means this resistance is irrelevant. It plays no part. Therefore, the current through this resistor should be 0. This problem came in ITJ back there. Next slide, sir. Great. As I told you, we'll work on some questions, the nodal method on capacitances also. Okay? So here is the question. Question number 3. This is 2 microfarad. 3 microfarad. Again 3 microfarad. 2 microfarad. And this is it. Okay. And he says find equivalent capacitance. I did the similar question of resistance yesterday. Yeah, remember? Now in nodal, I told you, when you deal with resistances, then the net current at any junction is, in capacitive circuits, purely capacitive circuits, the net charge is, right? Okay. Now, in that case, chalo, who will come and solve it for the board? Kaun karega? Aajo, come. Yeah, I'm sure you'll do it. Ultimately, the exam में आप ही को solve करना है. So good, we can practice here. I want to find out equivalent capacitance across this. So what would you take this as? V, and that as 0. Very good. And the potential of this point as X. Good. Okay. And what about this point? What should be the potential of this point? Yes. See, when the charge enters, यहाँ पर same, the same charge has to come out from here. Now this is 2 and this is also 2. That means the potential difference across this and across this will be same. What is the potential difference across this? So what should be here? This is 0. So what should this be? Good. Good. Now select this as your node. Encircle couples and write the node equation for this. Net charge has to be 0. Charge क्या होता है? What is Q equal to? C not V, C delta V. C 2 into what is potential difference? X regarded as the highest potential. X minus V, very good, plus 4. Okay, yeah, very good, plus, okay, equal to X solve. You want to solve it? आप वहीं पर solve करो. Do it there. Very good. I mean, you should clap for her here. Come on. Find the value of X. Speed up. Yes. What is the value of X? 6. Big, perfect. Now suppose. Now what does this solution gives us? Where is the edge? ये कितना हुआ? Right. ये कितना होगा? What will be V minus X? 7V by. Now see the edge this will give to you, which the other students won't have. A. If he asks you, what is the charge on this capacitor? It is how much? 7V minus 6V by 13. How much is this? V by 13 into 4. So what is the answer? He says, I want to find charge across this. How much is this? 14 by 13. Right? If he says, find C equivalent. What is C equivalent equal to? Q by V. What is the potential difference? V. What is the charge? Two directions in which the charge would flow. Yes or no? What is the charge in this direction? V minus 6V by into, very good, plus, what about this? V minus into, obviously, this will be into. Answer. This problem is in Cbse. It's a solved example. It takes more than half a page to solve it. Students follow Cbse like a Bible. It is a great book. But this entrance exam is not about greatness. It's about understanding and learning challenges. The more faster you can solve, the more edge, the better place would you be. The fourth question. You should not take more than 30 seconds to solve this. Because by the way, this V is on the top. Yeah? V we did the similar type of question yesterday on resistances. This is V and this is 0. And you have capacitance on every level. You have to find out C equivalent. And we have the students also. Can you see them, students? I think if you can correct Bhopal, because yesterday I had some calls from Bhopal. 30 seconds, 30 seconds. Fast, fast. Who would come on the board and solve it? Up, out, come. Hmm. Give it a try now. I'll help you. Take the red marker. Okay. Now, tell me one thing. I'll help you. Do you think that this point and this point will have the same potential? If I draw a straight line here, a diagonal, do you see that they both are the same potential? X minus 2. Good. This should be X. Right? Now, there are three directions in which the charge is. ये बचता है. इसको different लेते हैं. Let's take it as Y. Right. Now, these are all capacitors. You agree? Now, the charge which would enter from this side, say I take this as Q, and this also as Q. Maybe this is Q, right? The charge बाहर यहाँ से निकलेगा, right? That should be Q. This should be Q, and this should be, their capacitance is here. This should be, agree? Capacitance is same, charge is same. Therefore, this potential difference should be equal to this potential difference. What is this potential difference? Minus X. V minus X. V minus X should be equal to, what is this potential difference? X minus C. Right? What is X? Perfect. Now, which means this potential would be equal to this potential would be. Now, what you have to do is, you have to, let me just move this one. Now, this was Q1, and what was this? Capacitance is same, so potential difference should also be. What is this? This is, and the potential difference is, what is this? So what should this be? Oh. Now, when you solve a problem, everything should be in your control. Okay, perfect. Now, I'm left with these two. If I take this as X, I don't have an X, I only have a Y. Maybe X is here. You agree? If I were to take a node, say I take this node, equation with it. You know, I know you didn't come yesterday, but I'm sure Udaan ke students हैं, pick up करेंगे. Now you have to take this as the highest node. So this is the highest potential. So net charge, this plus this should be 0. What would be charge here? X minus V into C, okay, plus X minus, no, X, अच्छा, okay, where is V? Y, X minus Y, it should be X minus Y, no? ये ले लिया, this will be X minus V plus Y, इसको रख करो, V हटा दो, ये potential कितना है? X, ये कितना है? You need the potential difference, तो क्या लिखोगे? X, very good, fantastic, into C, and there is another one also, कितना? ये X है और ये, तो क्या लिखोगे? Plus X minus into equal to C. Very good. Right? Similarly, you can write equation for this node also, because there are two variables, so you need two equations. Y का लिख के दिखाओ. Okay. Fantastic. Okay. नहीं, आप इधर हो ना? You're on this node. This plus this plus this. Right. No problem. Okay. Good. Right. Right. Equal to. Fantastic. Good job done. Confidence बढ़ा कुछ? Yes. Find the value of x in y. Rock star. This girl is a rock star. You will not get less than 300 marks in mains. Be rest assured. I can tell this live. That what I've seen in you, if you continue to study with the same energy, you will be amongst top 100 in mains exam. Udaan will have the best result, one of the finest results. I'm telling you this. Absolutely fantastic. You know what speciality does she have? When she starts a question, she doesn't leave it in the field. ये जो शुरू करती है उसको खत्म जरूर करती है. Always remember in life you have to be a good finisher. All great teams have been built, whether it is cricket, soccer, finishers. खत्म करना है काम को, बीच में नहीं छोड़ना. Like for example, कितना बताया जी आपने x का वैल्यू? V. This is V. And what is y? 2V. So what is V minus y? Now tell me, can you find potential difference, charge on any capacitor you want? You name it and you have it. He says, tell me, sir, what is the potential difference in this arm? 2V by 3 minus. He says, please tell me what is the charge on this. This into this minus this into. Fantastic. Right? Now who is going to find C equivalent for me? Aja, come. Let the entire world see the next topper of IIT. Aja, take the red mark. Find C. Okay. Very good. What she's saying is this minus this into C. She's writing the charge. Same charge here. And this charge. What is this? Yes. Over. Always motivate each other. Round of applause for her. Yes. Very good. Fantastic. Great job. Have you understood nodal analysis now? I know. Now you would need some more practice on this. What I'll do is, sir, I'll give you a sheet. I'll give you 10, 15, 20 question sheet. Mail it to all of them. They will have an answer key also. If you can solve it on your own, good. If you don't, then in the next class, we will first take your doubts on those questions and then move on. The most important element is going to be your solving ability, which will only come if you solve more and more, not many, some good number of questions. Perfect? समझ आया? चलिए, let's move on to the next slide. Wow. Now this portion is RC circuits. आपको डर लगता है इससे? Are you scared of this? Have you done them earlier? Have you ever solved an RC circuit? अच्छा, सब लोग देख रहे हैं, मेरी बात उनको सुन रहे हैं. Very bad. Right. RC circuits. Resistance, capacitive circuits. You know the best part about RC circuits is, have you discussed rolling motion and rotation dynamics? Do you know what is rolling? Rolling is a combination of pure translation and pure rotation. And do you know the best part of it is? If translation happens, rotation cannot happen. And if rotation has to happen, then translation cannot happen. Then how do you have both of them together? The best part is, because they're independent of each other, you can have them together. For example, basic सा सवाल देखो. I'll take a simple question of electrostatics. 3 charges. Now, by the way, Coulomb's law dealt with only 2 charges. His theory is based on 2 charges. Imagine Karoa, if I were to find force on Q2 due to Q1, and I'm sure Q3 is also exerting force on Q2. But if I have to find the result for this, to find the net force on Q2, because of both of them, when I take a force on Q2 by Q1, I ignore Q3. And when I have to find force between these two, I have to ignore. This is called principle of superposition. Do you know superposition principle can only exist if they don't interfere? In pure rolling, you have pure translation, you have pure rotation, then you superimpose them. The same thing happens in RNC also. If you have a DC source connected to a capacitor, in a microsecond, it will get charged. And the current in the circuit becomes 0. If you have a resistor instead of a capacitor, and you have a battery, a continuous current will flow. Just imagine. Now you want to have both of them. You getting a point? Are you understanding what I'm saying? But if I have a capacitor, simple, and I connected this to a DC source, and I put a battery, and I put a switch, what happens? As soon as you press the switch, instantaneously this gets charged. Because of this, the potential here is CV, the potential here is minus. And immediately, the current becomes 0. So instantaneously, current will be maximum, and then after some microseconds, this current will fall to 0, completely charged. If I had an independent resistor with a battery, and I press this key, this goes forever. This continuous current would flow. I need both of them together. That is called an RC circuit. Right? Are you understanding what I put up a battery? That's a key. So this is C and this is R. Now, as soon as I press this, I call that instant at, say, t equals 0. What do you think is going to happen? This capacitor would allow maximum current to pass through it. It would allow this to get charged. When you allow maximum charge to flow, you assume this capacitor to behave as 0 resistance. Yes. If I put a capacitor and I put a battery, and I say maximum current would flow, which means what? The capacitor is not offering any resistance. So at t equals 0, how would this behave? Wire. Normal conducting wire. Perfect. So what would be the current? And in the steady state, which means when finally this capacitor gets charged, would any current flow? No. I would become 0. Yes or no? Initial charge on capacitor was 0. Yes. And finally the charge will be, you agree? Liquid. Write this down. But my question is, I want to know what happens in between. Say at time t equals t. He wants to know the instantaneous current and the instantaneous charge. That is why it is called transient circuits. Transition. During the transition from 0 to infinity, what happens in between? Now, one way to solve it is through integration, which is given in books. Now, I'll give you, as you rightly said, I'll give you a Brahmastra. All set. I'll give you one formula. You can use that formula in any problem. 30 seconds, you get the solution. Likho. Q on a capacitor at time t equals 0 is Q infinity minus Q naught e to the power minus T by R. You just have to remember this. Perfect. अब fill in the blanks करते हैं. How खेलते हैं? How खेलते physics? What is the initial charge on the capacitor, by the way, in this case? Fill in the blanks करते हैं. Perfect. What is going to be the charge on the capacitor at infinite time? Steady state? CV. Yes or no? ये CV? ये CV. Q कितना आया कैपेसिटर पर? Over and out. मस्त हो गया ना काम? Perfect. Now see the next question, 6th. There is only difference is it initially had a charge minus R C. आइए fill in the blanks करते हैं. पहले लिख लो आप बस. And we'll just do fill in the blanks. In the JEE preparation, we train students for tricks. Save their time. Start correct. क्या आंसर होगा? By the way, what will be Q naught? Q naught? What will be Q infinity? ये खत्म हो गया था. Finished. Okay. Perfect. Now, one more thing is sometimes in the exam they can ask you, since you are the result for this was CV into, they can ask you to plot the graph between charge and time. How do you think the graph would look like? Exponential? Growth? Yes. It goes something like this. Right? This becomes the maximum choice. Okay? Now, between 0 and infinite time, there will also be a time. I'll ask you, if I say t equals RC, what would be the RC? Put this in this formula. कितना value आ रहा है? And what is it? What is E equal to? करो, निकालो. What is the value coming out? 63% of, and what is CV? The maximum charge it can actually store. That means if this time is RC, then this value or 0.63 CV, right? This RC, girls, is called the time constant. So if somebody says tau is called the time constant, tau, this is RC is called tau. It's written like this, right? This is RC. This is called time constant. If somebody says, what do you mean by time constant? It actually means time in which this circuit will grow up to. 63%. Perfect. Now, if I were to give you a Q naught and a minus Q naught, and now I ask you to draw a graph again, can you plot it for me? There was an initial charge Q naught. Now I charge it. What do you think the graph would look like? How would the graph look like? Yes. Shift हो जाएगा. कैसे होगा? Yes. Good. 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 Start कहाँ से करोगे? Q naught से. Initial charge कितना होगा? Q naught. बनाओ. Draw it. Initial charge will be Q naught. And what will the maximum charge? Cb, yes or no? Something like this. This would be. And this would be. Yes or no? What would be this difference equal to? Here. Next slide. Now imagine a situation. Now, till now, you had one resistor, one capacitor. Case 1, capacitor was uncharged. Case 2, capacitor was initially charged. Capacitor. Imagine you have many of them. You have resistances are more or capacitance is more. What do you do then? Have a look at this question. By the way, this problem has come in IIT JEE. It's a previous year question. Don't get scared. It's a very, very simple problem. Before leaving today, I'll give you a question. I will give this question to all school students across Udaan. In my next class, if you give me a correct answer, I'll request the Udaan team to felicitate that student. I'll give you a challenge. I'll give you and believe me, that question, all of you will attempt. I want to see how many of you do it correctly. It will be based on Coulomb's law. Get ready. Before I stop my lecture, in every lecture, I give one challenge problem. And the best part about the challenge problem is, if you know it, less than 1 minute. If you don't know it, you'll always do it wrongly. मैं train करना चाहता हूँ आपको. You get used to this habit of solving problems between 1 to 2 minutes. That is why I've devised these methods which can make your life simple. Have a look at this question. 3R, R, C, V, switch. The question he's asking is, find the charge on this capacitor. What would you do? Think and tell me. Today I'm going slightly slower because I want you to absorb also. Take your time. अच्छा, give me your thoughts. क्या सोच रहे हो? अच्छा, अभी तक जो क्वेश्चन आपने किया, you had one resistor and one. सब लोग बोलो. And resistor. You were comfortable with that? Problem क्या आ गई? 2 लूप बन गए ना? एक बना दें इसको. Okay. When I close the switch, this potential difference is going to come across this and also across will this potential difference ever change? ये जैसे ही मैं बैटरी को इसको बंद करता हूँ, I close this V comes across this, and the same V comes across this. Do you think this V is going to change? It's not going to change, right? Redraw this circuit. Yes or no? इसके ऊपर चार्ज कितना? आंसर बता. क्यों? फॉर्मूला क्या था अपना? Cb, okay? T by tau. Now we'll see tau. We'll have to check out the value of tau. यहाँ पे ठीक है? पक्का? अच्छा, if I differentiate this function, I want to find out current in the circuit. Suppose I want to find current, then I'll be able to find out this. What will be I equal to? Differentiate this function. जल्दी देखना नहीं, वैसे बताओ क्या लिखूं? Okay, e to the power by tau. Perfect. Yes or no? पक्का? ये current कितना? I call this as I. How much is this current? By the way, what is the total current? Cv by e to the power minus plus v by. Do you understand this? You've actually created a single loop from two loops. एक thought रखा, v will remain. Now in this question, have you understood this completely? The only thing which I have to find out now is, and what is tau called? Time constant. Now I'll tell you how to calculate the time constant. Likho. How to calculate time constant of a circuit, or should I say RC? Okay. I will not use big names. I mean, for example, if I were to say circuit solving tau is done by Thevenin's theorem, I don't want to confuse you with this. अब मैं आपको इसका तरीका बताऊं. You see this circuit? You see this battery? To calculate tau, battery. क्या कहा मैंने? Number one. This is step number one. Short the battery. Step two. Do you have more resistances or more capacitors? Single क्या है इसके अंदर? Open circuit the capacitor. ये कर दिया. Step two. Find equivalent resistance between A and B. Resistor को जहां से आपने कैपेसिटर को जहां से हटाया, you actually removed it, you created an open circuit. वहां पर उन दो पॉइंट्स के क्रॉस, tell me what would be the equivalent resistance. इस सर्किट का equivalent resistance होता है. By the way, this itself is a question. 3R by, I mean, when I say equal resistance, it is 3R. No problem. 3R. Are you sure? Let's see. That's 3R by 4. Incorrect. Incorrect. Karo. Come on, do it. Yes. Have the spirit. बहुत ही आसान है ना? It doesn't look very, very simple? Yes or no? That is the speciality of IDJ. They're so beautifully made that you can actually, if you know it, concepts are clear, then you'll be able to solve it. अगर आपको नहीं मालूम तो फिर आपसे होगा नहीं. Check it. Come on, guys. Wrong. Try again. Try again. पता नहीं, ये तो आपको बताना है. अब एग्जामिनेशन हॉल में कोई आएगा नहीं आपसे मिलने. आप हाथ सर ये पैटर्न में सीरीज में. Tell me, what is the equivalent resistance? I give you a hint. Hint do? Zero. Hint, it doesn't mean zero. Hint do aapko. If I tell you the correct answer, can you tell me the logic behind it? Are you smart enough to do that? The answer is R. R. Why? नहीं जर्मनी और फ्रांस के बीच. पागल मत बना तो मेरा. ए और बी बहुत देर से डिस्कस हो रहा है. ए और बी हो रहा है ना बार बार डिस्कस. टोटल कुछ नहीं. व्हाट डू यू मीन टोटल? रेजिस्टेंस इज ऑलवेज अक्रॉस 2 पॉइंट्स. व्हाट डू यू मीन टोटल? हाँ टोटल ही चाहिए. टोटल बिटवीन ए एंड बी. मिस रोहिणी बताएं जरा. आपने घुमा दिया सवाल. ए एंड बी आर क्यों? आई थिंक यू हैव एन आंसर. So we have decided today that I'll give you a challenge question before I leave the class to the entire 400 students or whatever girls are studying. You know the answer, you will solve it incorrectly. Take up any book, search Google, Wikipedia, do whatever you want. I'll give you a very simple question and I promise you'll do it wrongly. I want you should do it correctly. जैसे ये सवाल. Tell me, if this question comes in IDJ, there are and there will be 4 options. And the best part is the wrong option is always C. है ना? क्यों कार? क्यों नहीं जाएगा? उसको जाने का रास्ता ही नहीं, उसको वजह ही नहीं है जाने की. Yes or no? When I say find equivalent resistance, I apply a battery here. हाँ है ना? The current starts here, comes here, does want to go in both the places. But there ही जैसे यहाँ पहुंचता he realizes on the left there is no resistance. तो मैं जाऊंगा यही जहाँ resistance नहीं होगा. तो ये पूरा करंट घूम के ऐसे आ जाएगा. This has no role to play. Understood? Or should I repeat again? मजा आया कि नहीं आया? ये बात. Simple question, very simply done, applies great concept. This is called short circuiting. ब्रिज बनते ना फ्लाईओवर्स, ये फ्लाईओवर. ये सारा का सारा रूट, सारा का सारा ट्रैफिक इधर से पास करे, इधर जाएगा ही नहीं. अंडरस्टूड? मजा आया कि नहीं आया? सो व्हाट वुड आई डू हियर? व्हाट वुड बी टाउ बी? कट दिस. द आंसर इज v by r e to the power minus t by rc plus v by, लिख लो उसको. परफेक्ट. ठीक है, एक क्वेश्चन और दूं. चैलेंज प्रॉब्लम. लेट्स सी. एक लड़की तो डिसाइड हो गई है. शी इज गोइंग टू गेट 300 मार्क्स. यस? हाँ भाई. यस और नो? व्हाट यू आर प्रॉमिसिंग मी? 300 मार्क्स and you will be amongst top 100 in the Udaan program. Now let's see, out of 3, 6 to 8. So how do I perform it? Bhopal, can you connect Bhopal? Yesterday I received a lot of queries from Bhopal and they wanted to connect. Can we have doubt sessions also? Or if some other class in Chennai is there. So I'll give you a final question on the resistance. This is. Hi Bhopal, can you hear me? If you can, raise your hands, please. If you can hear me, just raise your hands. Okay. Now, let's see the challenge question. All set? The final question of circuits. Then we'll move on to magnetism. If there has to be a good question, if it has to come in IITJ exam, entrance exam, this is going to be the question. Let's see. Now the question is, this switch is closed. Steady state. Right? I open the switch. What charge will flow to the battery? That's the question. I'll repeat the question again. The switch is closed initially for a very, very long time. You open the switch. What charge will flow from the battery to the capacitors? Right. Answer. 3 minutes are gone. Right. Answer. And if I ask you a different question, a more interesting one. When you open the switch, are they in series? Are they in series capacitors? I'm saying in this condition, are they in series? Yes? No. Welcome to the world of IIT. No. जो दिखता है वही नहीं होता. Don't go on the face value. अब मैं prove करता हूँ. I'll prove this. Neither they are in series, nor in there. They're in parallel. तो है ही नहीं. But they cannot be in series. Now, how do you recognize two capacitors in series? You say, sir, they are in series, right? This is not the condition for series. Let's first do the first part and then come to the second part. By the way, two capacitors are in series only if the net charge on this system is 0. This is called isolated system. Why they are isolated? Because when you connect this through a battery, this plate can have a charge from here. This plate can have a charge from here. But these two plates, this net charge has to remain constant. And if they are in series, this charge has to be 0. याद रहेगा ये? Note कर लीजिए इसको. capacitors in series, the net charge on the isolated system is going to be 0. Okay, now let's come back here. I said this was initially closed. How would the charge flow? Like this, and I told you, short circuiting. What would the charge here? And here, 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 perfect. And the back, switch definitely is closed. Now I open this. Now my question is, when I open this, will any charge flow from here to here? Now, one, I'll give you an explanation which is less than 30 seconds. The second, because you are students, you should also learn. We'll first use nodal analysis. We will do nodal analysis. And then I'll tell you that without nodal analysis, also you could have found out. Tell me one thing. When you open this potential here will be V. This potential will be, because let this potential be. Write the nodal equation here. बोलो. X जोर से बोलो. Minus B into C. Perfect. आगे बोलो. Into ये किसके बराबर होगा? Now, when you open this or you close this, ये जो charge है, can it go anywhere else? Does it have any path to go here and there? So will this charge ever change? In this case, what is the net charge here? Note it down, star लगा लो. ये आपके लिए सबसे important tool बता रहा हूँ मैं आपसे. And I promise you, again, you don't find it in books for sure. So whatever I'm telling you right now, write it down और इसके ऊपर एक डब्बा बना लो. We will not forget this before we go to our exams. Before the exam, revise this concept. I told you, two capacitors are only in series if the charge on the isolated system is 0. And if it is non-zero, definitely they are not in series. But then how do you use them? In the nodal analysis equation, this is not going to be 0. Instead, it's going to be X कितना आ रहा है? How much is X? Yes. X कितना आ रहा है? Oh my God. That's so interesting. इसका potential कितना निकाला आपने? And what is the potential of this element? What is the potential difference? What is the charge? पहले कितना था? अब कितना है? कितना फ्लो करेगा? That's the answer. Magical है ना बिल्कुल? Isn't it absolutely magical? And can you believe it? They're not in series. They're not in, because the net charge here is. Now, we'll solve this question in 30 seconds. All set. Complete concentration here on the board. There were two capacitors. There was a potential difference. There was a path from which this charge would flow. This got CV, this got minus CV. This was 0, this was 0. What is the total charge this battery could have given to the system? CV. उसके बाद कहां से लाओगे? This capacitor could have got charge CV. Got charge CV. What is the maximum charge this battery could have given? भाई potential difference V है, capacitance C है. Maximum charge कितना दे सकता है? अब आप इसके बाद 500 capacitors लगा दो. Put 2000 capacitors. When it cannot give charge, how will they get charged? Getting my point? Therefore, there will be no charge flowing in the circuit. Now, if they have to up the ante, now have you first understood this? Now, if you have to raise the bar of the question, they can ask you again. When you open the switch, what is the work done by the battery? Done by the battery? Charge into potential difference. How much charge it flow? What is the work done? That's it. Come on, bro. Understood? These are the questions, these are the tricks, these are the methods you have to get used to. The faster you get used to them, the better for you. Now let me ask you, have you read and come today, magazine? Can I believe that you know the theory? Now I have for you a very interesting thing. What does it say? Why an electron beam, while moving with small velocity, diverge, and while moving with large velocities, converge. What is the difference between? Tell me, what is the difference between cell and a capacitor? By the way, what's the difference? In a capacitor, what does capacitor do? By the way, stores energy. It stores energy, and that energy is fixed, constant, right? And what does the battery do? It does the same thing. There is a potential difference, but what is the difference? There is a dynamical process which is happening inside a battery. Electrolytes are formed. Dissociation is happening inside a capacitor. Electrostatic energy remains constant. अच्छा, by the way, where do you use capacitors? Any use of capacitor? कैसे क्या use क्या होता है इसका? What is the use of a capacitor? They use as starters. They're instant energy boosters. If you need initial energy to start up, those behave as energy boosters. Battery on a different note, it continues to maintain a constant potential difference and becomes a source of current and electricity. To give you that magnetism thing. Now, if I were to assume that you have done magnetism, I have got this for you. And by the way, this is called a mind map, which you all have to start drawing on your own. No, not here. I'll give you this printout. What I mean by this is that for every chapter you do in physics, chemistry, or mathematics, please understand, one day before the examination, you won't have time to revise everything. If I were to say revise magnetism, you will have like 100 sheets to revise from. But if you draw these mind maps on one single page, you have the entire magnetism as well as the formula goes. Right? Do we know the Biot-Savart law? I can assume that you know that. Just go through the derivations. Just go through the results. Just write these results if you want. Results, just the results. You're aware of these results? Biot-Savart law. Field due to a straight carrying conductor. यही होता है? Yes. Infinite is 2I by d. Yes. Arc V0 by 4 pi I phi by r, है ना? Where phi is the angle, तो मालूम होगा ना आपको? Okay. The fifth one, solenoid. Okay. So sort of current can do. Remember this formula, torque M cross B? Perfect. Assuming that we know this one. Before I go to the next question, in electrostatics, you can put the slides. If I were to ask you, there's a charge plus 2q and there's a charge minus 2. Plot electric field versus distance graph. Or I ask you, where is the null point? in this question. Two things, null point and E versus the distance. Then we'll move on to the current versus distance. No, next. Max distance. We can go to the max distance slide. Now, actually, we have very less time. So. Okay. Now I'll give you a very good method to find out. Tell me one thing. Electric field is inversely proportional to radius, square the distance, not radius, the distance. You agree? And you also know electric field is a vector. Yes or no? And we also know E is minus dV by. Now suppose there are two questions. A, I want to find the null point. Null point means where the net electric field intensity is. Now, if I can draw a potential versus distance graph, wherever the slope is 0, electric field will be. अब मैं आपको 30 seconds का मेथड सिखाता हूँ, सब लोग ध्यान से सुनो. Electric potential is Q by R. Electric potential is a scalar. It is positive when the charge is positive. It is negative when the charge is. When R will tend to 0, E will tend to infinity. And when R tends to infinity, E will tend to how? शुरू करते हैं. Let's start. This charge is plus Q, this is minus Q. Due to this charge, what will be the potential at a point which is very, very close to this? Infinite. This distance R is very, very small. So therefore, the potential will be plus infinity or minus infinity. Now, plus is on the top, the negative is on the bottom. मैंने यहाँ पर एक छोटा सा line दिया. On the right hand side, is the potential plus or minus? Positive or negative? Charge is positive and the distance is very, very, it will tend to this charge is negative, so the potential will be, and it will be infinity. यहाँ पर. Now, I'll take a point which is very, very far from this. What is the total charge here? Plus or minus? Total charge. At infinite distance, the potential will tend to 0, right? Positive, negative, 0. Positive, negative, 0. Total charge is what? Positive or negative, 0. काम खत्म हो गया. This is negative infinity. है ना? And this is, so the graph will first go up. Yeah, will reach a maxima and then where is the slope 0? And slope कितना है? ये null point. 30 seconds. Start. जल्दी करो. दोबारा बता. You want me to redraw the diagram again? Up. Come on the board. You know, whenever a student asks me a doubt, I get it removed from a student. Marker, red marker. Find potential. We are finding out potential at this point, very close. This point, very close and very far off. At this point, potential plus or minus, positive or negative? Positive. Infinite, it will be infinity. कहाँ दिखाऊं? I want to show everything positive is up, negative is down. कहाँ दिखाओगे? Very good. See, when you have a charge here, on the left hand side, on the right hand side, again positive. दिखाओ. Very good. यहाँ पर दिखाओ. Negative कहाँ है? नीचे. Very good. Very good. Now, when I go very far off, these two charges will look like one. What is the total charge? Positive. So the potential will be positive. And at infinite distance, the potential will become positive 0. Positive 0. The graph, you know, B is inversely proportional to R. The function is a hyperbolic function. You know how hyperbolic functions behave? Connect both of them. समझा रहा नहीं? Now you are wondering, ये ऊपर जाके बल्ज क्यों आ रहा है ऐसे? ये नेगेटिव इन्फिनिटी है, पहले जीरो होगा, इंक्रीज करेगा, फिर जीरो प्लस का होगा. यस और नो? This is the easiest way to do it. Have you noted this down? Now, why I this did was, this will help you in understanding the first question I'll give you. Imagine a situation. Give me the second question first. Third. Yes. Have a look at this question. This problem has come in IITJ. What does a dot represent? It is coming. अब पहले आप मुझे बताओ कि ये दो I है, ठीक है? I'll use the same method here. What is the value of B? B depends on hyperbolic functions. High enough. Now, if I have a dot, that means current is going like this. If I wish to calculate the value of B here, what is the method you follow? कौन सा method करते हो? I'll give you a method. Use right hand. No, not thumb rule. Palm rule. The right hand, palm. I'll tell you how. The right hand, I want to find the value of B here. Thumb in the direction of current. And fingers in the direction in which I want to find out B. यहाँ पर B downwards है या upwards? Downwards is negative. Upwards is tending to ठीक है, इधर पॉइंट लेते हैं. राइट हैंड, थंब, फिंगर्स इन द डायरेक्शन विच आई वांट टू फाइंड बी. कहां जा रहा है? इधर से. थंब क्या निकालना है? कहां जा रहा है? डाउनवर्ड्स. कहां जा रहा है? कौन सा ग्राफ होगा? Which and when you go to infinite distance, आया ना, this will tend to 0. yes or no? कौन सा ग्राफ मैच कर रहा है? ये ऐसे बनेगा. yes or no? Understood? ये मैग्नेटिज्म का जेई के अंदर आपका फर्स्ट क्वेश्चन. क्लियर? ठीक, कोई. एक ट्राई करोगे क्वेश्चन? एक काम करते हैं, इसको 2i ले लो, उसको i ले लो, इसको क्रॉस ले लो, उसको डॉट ले लो. We did this question. take this as cross 2, this is dot I, dot करना. Let's do that more. Take it. Cross means inside. लेके जाओ. इधर आता है. क्रॉस, ये ठीक है. हैंड खोल, एंड ऐसे खोल, ऐसे. कहाँ जा रही डायरेक्शन? नीचे. देखो. गुड. अभी इधर आ जा. देखो इधर. फिर ले जा थंब. ठीक है. कहाँ जा रहा है? वेरी गुड. अभी इधर आ जा. ऐसे. ठीक है. अपवर्ड्स. फैंटास्टिक. इधर. ये राइट हैंड, ये ऐसे. कहाँ जा रहा है? तो कहाँ जा रहा है? ऊपर नीचे. ये बाहर दिखा रहे हो ना तुम? कैसे दिखाओगे? ये तो बाहर हो गया. ये ऐसे. ठीक. एंड द टोटल करंट इज प्लस और माइनस क्रॉस. नेट क्रॉस बचा. इनफाइनाइट डिस्टेंस पे आ गया. क्रॉस कैसे दिखाओगे? क्रॉस है. दिखाओ. राइट हैंड को. ओके. अपवर्ड्स. यस. बनाओ बनाओ बनाओ. इधर ले जाओ. क्रॉस. क्रॉस ऐसे. कहाँ पर? क्रॉस ऐसे है ना. यहाँ निकालना है. डाउनवर्ड्स अपवर्ड्स. डाउनवर्ड्स कहाँ दिखाओगे? नहीं. इनफाइनाइट डिस्टेंस. नेगेटिव नेगेटिव. डाउनवर्ड्स. बना के दिखाना कैसा बनेगा. वेरी गुड. एक्सीलेंट. जॉब डन. रॉकस्टार है कि नहीं? अंडरस्टूड. आपने पहला पड़ाव क्लियर कर दिया. दिस इज गोइंग टू बी योर फर्स्ट क्वेश्चन. इजी मेथड हो गया. सिंपल. चलिए आगे जाओ. Let's go to question number 2. One. Question number 1. Have a look at this question. Can we solve this? I think we can solve this. Simple है ना? करके दिखाओ जल्दी से. Do it fast. Current is I. We have to find out the net magnetic field at point C. Two semicircles. पहले बताओ मुझे B ड्यू टू अ सर्कल कितना होगा? फटाफट. How much? mu naught by 2 I by. पक्का ना? सेमी सर्कल तो कितना होगा? 4. एक होगा R1 and the second will be mu naught by 4 I by. अच्छा. If this is A, this is B, this is C and this is D. Now let's find magnetic field B due to AB at this point. इसको P. कितना होगा? I want you to tell me the magnetic field due to this element at this point. 0. Why? Ideal cross R. This is ideal. This is R. So the angle between them is 0. So ideal cross R will be very good. Let's see B due to BC. Mu naught by 4 I by R. Direction. Magnetic field will be inward or outward. कैसे निकालते हो? कुछ करने की जरूरत नहीं है. यहाँ बैठ जाओ. Sit here. ये आपका ऑब्जर्वर है. If the direction of current is clockwise, minus k cap. If it is anti-clockwise, plus k cap. समझ आया? If you are sitting here, this direction is clockwise. And B due to CD will be 0. And B due to AD will be I by plus minus. You sit here, this is anti. The direction becomes very, very important. Students get confused between the right hand and the left hand rule. So the best way is sit where you have to find B, observer ko wahan bithao, see whether it is clockwise or anti-clockwise, clock minus anti-clockwise. Perfect. Second question. Next slide. The second question. Have a look at this. The question says dot across infinite current carrying conductor coming out and infinite current carrying conductor going. Okay. We want to find the net magnetic field. The distance between these two conductors is 2a. This is a, this is a. If I were to find out at a distance x, what would be the net magnetic field at P? This one P. पहले तो ये बताओ मुझे, what is the लिखवाया था मैंने, you not buy, right? कहाँ निकालना भी? कौन करके दिखाएगा? Who's going to come? Right to come now. Come. Come. That's how you will learn. Get the red mark. B कहाँ निकालना है हम लोगों को? Point P. अपने हाथ right hand निकालो. The right hand है. कहाँ निकालना है B? इस पर. And where would your thumb go? करो लेके आओ, थंब को पास लेके आओ, जब कंडक्टर के पास थंब को लेके आओ. करंट कहाँ जा रहा है? करंट कमिंग आउट. Very good, very good, very good. So it will be upwards. Now tell me, when I say B equals mu naught by 4 pi I dl across R, B का डायरेक्शन I और dl दोनों के परपेंडिकुलर होगा. I कहां पर है? Z एक्सिस. R कहां पर है? ये R है. ये R हुआ ना. इसके परपेंडिकुलर कैसे दिखाओगे? फैंटास्टिक. बी. काफी बड़ा बना है, छोटा बना है ना. आप बताइए, ये इतना छोटा बोर्ड है, कहां तक ले जाएंगे इसको? छोटा ही बना दीजिए इतना. चलो, बी. गुड. B1. अब इसका बनाओ. and the direction will be thumb. Yeah. B same होगा ना, B2 B1 will be same. Yes or no? Find B net. It's a very simple chart. Find B net. Very good. ठीक बनाया. Perfect. Great job. Good. Very good. Amit, no, no, we are not ignoring R. We already taken R now. Which R are you talking about? Which R? We already taken radius R1 and R2. So they're asking that question. दोबारा बताओ. Just show me that question again. मुझे दिखाओ. Correct. अच्छा. Manju. अच्छा, by the way, you tell me, why did I ignore R? Who will tell me? Did I ignore R ignorantly, or was it intentionally? Intentionally किया होगा by default. Now, Manju, I'll tell you one question came in IITJ. Just have a look at it. The question is, when we close the switch, what happens to the charges? I'll take both the charges as same. CC. What happens to the charge distribution? What do you think? Will the charge move? Right. I told you, charge or current has to move in a closed loop. Till the time you don't connect them, this charge is not going to move. Are you getting my point? Now, in this question, till the time I don't connect them, there will be no current which will be flowing through this resistor. That is why we ignored this resistor. Clear? देखो इसको note करो. Current or charge has to move in a closed loop. Perfect? Very good. Okay, I'll take one more question. This is X, this is Y. All set? I want you to tell me what is the value of magnetic field intensity of current. Try. G. Yes. The current goes like this, the wire is like this. The shaded region tells you the axis, minus infinity or plus infinity to the minus infinity. So the current carrying conductor is coming from plus infinity, takes a turn, goes like this, goes to minus infinity. Find the magnetic field. He says, can you explain RC circuit again? Okay. What does the shaded region, what happens when two conductors? Yeah. Okay, tell me, in which plane does this curve lie? Z? Why is it plane? Why is it plane? Are you sure? If you have a Y here and you have a Z here, ऐसे नहीं. So it's a quarter of a circle, fourth part. क्या लिखूं? अपन. ठीक है? Direction clockwise, anti-clockwise. फिर कहाँ बैठे हो आप? You sitting here. So minus, and the plane is Z Y. So minus. What about this? This is Y Z. Again, quarter, mu naught by 8, I by R. What is this plane? Y Z. Same आएगा ना? Great. थोड़ा चेंज करते हैं क्वेश्चन. Acha. What about this? What magnetic field will this wire produce? And this also? Now the current goes like this, and then comes back. Magnetic field intensity at point. What would change? Will this change? Same. This will remain. What about this? mu naught by 8, I by R. And what is the plane? So it will be minus K. This is Z. This is X. Perfect. Baka. What is the name? Rishi. Rishi, you asked me that why in a magnetic field the kinetic energy of an electron has no effect. Can you tell me? If a charged particle is moving in a magnetic field, are always perpendicular. Absolutely. What is the value of force? Magnetic force? Q V cross B. So by default, force it will always be perpendicular to, which means the work done will be 0. Therefore, the change in kinetic energy will be 0. So Rishi, There'll be no effect of magnetic field. Yes, and what happens in electric field? When you put a charged particle in electric field, it experiences a force. There is a change, there is a work done, and there is a change in kinetic energy. Right? Perfect? So, slide दिखाना. Then we have the next one. Yeah, question, next question. Third or fourth. Okay, now, let's come back to forces. Force, as we were discussing, forces Q into V cross. Let me take the first, a very basic problem. Say in this region there is magnetic field. B naught minus A. Now we are going through a very interesting phase. This is a very important concept. Say I say a positive charge particle. So this is y-axis. This is x-axis. V naught velocity से enter करना. कैसे करें? How would you move? How would you start the question? What would be the trajectory of this charge? सर कैसे पता? कैसे पता? आपने अभी बोला ना कि force is perpendicular to. And when do you have force perpendicular to velocity? In a circular path. Tangential. The velocity or force, radial force, tangential velocity, हमेशा circular motion में ही या circular trajectory पर सुनो. If I'm not saying circular motion, a trajectory will be circular. कैसे होगा? ऐसे? वापस आएगा? It'll come back the way it traveled. The velocity with which enters, the same velocity it has to come. Now, my question is, suppose the magnetic field dies at this point. Correct? This distance is d. By the way, what will be the radius of the circle? We all know that. mv by qd. mv by. Now, my d is less than r. Now, my question is, when it comes out, it will come out like this. What is the angle it makes with the x-axis? What is the angle? This charged particle Rohit, when charge concentrates on the surface of a conductor, why do we assume volume charge density? We assume volume charge density in the case when the medium is non-conducting. It is a dielectric. We call it a dielectric spherical shell, right? If I have a hollow conductor or a solid conductor, charge नहीं बाहर आना है. But if I have to show volume or concentration of volume charge inside a volume, वो कब possible है? When it is not a conductor. We call them dielectric spheres. In dielectric spheres, the charge is in the entire volume. Hi. Can you hear me? Hi, how are you? Oh, which place are you from? You are from DPS? Huh. DPS Bokaro. Oh, hello, DPS Bokaro. DPS Bokaro or Bokaro? Okay, tell me. Of course, I'll give you, I have a question for you. I'll give you a question. The first question, what you're saying is if you have a neutron, electron, proton, and an alpha particle, how would the deflection be, right? Yeah. Just solve this problem. The first problem of in my PPT is the same question. This question, question number 4, is what you're asking. We'll come back to that question. Give me 5 minutes. First, finish this, then we'll discuss that question. This concept is based on a concept of mass spectrometer. Yeah. Right. Now, tell me, how do you find the value of theta? Okay. I tell you one thing. When this charged particle is coming out, say with certain velocity v, what will be the direction of force? Yes or no? When it enters this point, what will be the direction of force? No. Now, wherever these two perpendiculars meet will be the center. Yes or no? And this automatically becomes the radius. This automatically becomes the radius. Yes or no? अभी ठीक है. Okay. Number 1. बनाया? Now, this is velocity. This is force. Agreed? Right? The angle between the x-axis and the velocity is theta. Now, this line is perpendicular to this. This line is perpendicular to this. So this angle will also be Ayana. What is this distance? And what is this distance? And can I say perpendicular upon hypotenuse is what? So what is sine theta equal to? Yes or no? So, and what is r equal to? That's your answer. Understood? Write this down. Sine. Understood? Should I repeat it again? Well, let's get back to the question number 4. Clear हो गया? Absolutely? अच्छा, ये जो मैंने आपको एक बात बताया अभी, it's a very interesting thought. How do you find center of a trajectory? Like, for example, if I were to, in a projectile motion, when a body is moving along a projectile, I'm saying that at this point, the velocity is v. And this angle is theta. Can you tell me what will be the radius of curvature? Because we just now found out the center and the radius of curvature. What is r? The radius of curvature. If it is a circle, then radius of curvature, the radius is the same thing. But if the trajectory is different, then radius will be radius of curvature because it will keep changing. Can you find out? Try that. Can I answer that question? Can I answer this question? See, DPS Bokaro, you say that how will we deal with situation where the movement with the movement of electron and when the electric field and magnetic fields are not perpendicular to each other. See, Lorentz force. What does the Lorentz force say? You tell me. Do you agree? Right? We can use this relation to find out the result. And whether E is perpendicular to B or it has a certain angle, we can always write them in the vector form. Find this vector equation, we'll get the value of force. Not necessarily perpendicular हो या ना हो, it doesn't matter. कैसे निकालेंगे? Is it a circular trajectory? Yes or no? No force. We just now found out. Perpendicular to कहीं यहाँ पर लाई करेगा. We assume the center is here. Yes or no? In a circular trajectory, what is R equal to? Yes or no? What is AR? Acceleration along the center. Where is the center? Here is the center. What is the net acceleration of this body? It is a projectile under gravity. What is the net acceleration? G. The net acceleration on a body or a projectile is always, what is this angle? What is this angle? What is this value? What is this value? Understood? Understood? In any circular motion, if you have to find center, draw a line perpendicular. Line पर circle में क्या होगा? Velocity tangential होगा, force radial. Step number 1. Step 2, when you have to find R, the radius, it will always be V square by AR. Okay, perfect. Now, question number 4, please. Just have a look at the question. The girl had asked this question. देखो ध्यान से. A neutron, a proton, electron, alpha particle enter a region of constant magnetic field with equal velocity. The magnetic field is always inwards normal to the paper. The tracks of the particles are labeled. The electron follows track. What are the tracks these particles follow? What about the neutron? See, neutron goes undeviated. Why? Because it doesn't have any charge. Now, how do you decide about A, B, and D? In सब में difference क्या है? ऐसे एक बात तो ये बताओ. One thing is there. We definitely know that positive charge and a negative charge would behave absolutely opposite. So, if we have a proton and an alpha particle, so this should be these curves. And if I'm dealing with electron, this has to be this curve. Now, if I have to differentiate between A and B, what is radius equal to? mv by q. इसमें सिमिलर क्या है? इसमें डिसिमिलर क्या है? m by q. रेशियो सबसे ज्यादा किसका है? अल्फा पार्टिकल. रेडियस सबसे ज्यादा किसका होगा? अल्फा. Between B and B, which has a bigger radius of curvature? B. So the right answer will be B. So this is proton, this is alpha, this is, and this is some what? Liquid. Very good. Now, Rajesh Avasti, your question is that when we put a slab does not deviate and disperse light, whereas prism does. What do you think? What is the deviation in a glass slab? Nil. Zero. Parallel ray, जो रे आती है वो पैरेलल ही बाहर चली जाती है. Yes? Yes or no? So that means the ray does not deviate. What is the reason? Because the planes are parallel. You have air here, you have glass here, you have air here. जितना deviation इधर होगा उतना ही deviation उधर होगा, and since they are parallel, the deviations will be okay. Now we move on to the next question. Question number, oh, that's an interesting question. Try this. Try this. It's a good question. चलिए मैं आपके लिए ग्राफिकल सिचुएशन बना के इसको ईज आउट कर दूं. X-axis V naught minus k cap, and the charge particle is a positive charge. Yes, it is a enters with a velocity V naught charge. How is this particle move? Uniform magnetic field, a charged particle perpendicular to the magnetic field. How would the charged particle move? It starts at t equals 0. अच्छा एक चीज और ध्यान रखना. You know, I had a student. I taught a student called Arnav Agrawal. He finally became a rank 19. I asked him that, Arnav, the way we prepared you, you should have been in top 3. He said, sir, something miserably wrong happened. I think what happened? He says, sir, in the 3 hours when I get to write my exam, in the start 10-15 minutes, I was jittery. Number 10. Sir, in the last half an hour, I got tired. My brain stopped working. Just remember, the startup and the end, as I said, finisher. Now, in the last 15-20 minutes of a lecture we have today, I want your maximum energy levels boosted up. Can I expect that? Yes? Come on, let's do it. आखिरी के आधे घंटे के अंदर वो सबसे critical phase होगा आपका, because you would have done your questions which you knew. Now, in the last half an hour, you will be left with questions which you are not sure of. Your body is receding down. Your energy level is falling. You're feeling sleepy. You're feeling tired. And you have to solve your best questions. Prepare yourself now. This preparation is absolutely imperative. Can you do that? Now, my question is, the first question is, the magnetic field is uniform. You said when a charged particle moves perpendicularly, enters the field perpendicularly, because the force is Q, B, cross B. So, in this case, V and B are already perpendicular. The force is anyway perpendicular to both V and B. So, the force has to be radial. Radial means it will go in a circular motion. He says if this is t equals t 0 and this is t equals t, what will be the velocity of this charged particle here? And what will be the coordinates if this is y-axis, this is x-axis, and this is origin? Let's do it. Come on, let's do it. Find the value of v. अभी थोड़ी देर पहले निकाली आपने. Tell me, how would this charged particle behave when it enters inside? Force कहाँ लगेगी? आवाज जोर से. Come on. Direction of force will be along y-axis. Yes or no? The velocity is along x. So this has to be here. Force ऐसे लगेगी. When it reaches here, this will become Right. Now, tell me one thing. Let me take this angle as theta. Even this angle will be theta? We just now found out. Can you tell me if it enters with speed v naught, will the speed here change or remain same? Same. वो हमने discuss किया था ना? Because in a magnetic field, force is always perpendicular to velocity. So there is no work done. So there is no change in kinetic energy. So there is no change in speed. It will remain. ये कितना होगा? And this will be yes or no? By the way, what will be theta equal to? Omega into t? And what will be omega in this case? Can anybody tell me? Omega की वैल्यू कितनी होती है? 2 pi by? No, that is okay. In terms of magnetic field, who knows? Who remembers that? निकालो, derive करो. Find the value for omega. In terms, I want theta in terms of omega. Tell me the value of omega. Absolutely right. Omega is QB by N. Impressive. Very impressive, right? Tell me, what will be the components now? क्या लिखूं? V naught? V naught cos, everybody, जोर से बोलो, V naught cos omega t I cap plus sine omega t j cap. And what is the value of omega? Q. So this is the dependence of speed on time. Perfect. Now he wants to find out. अब बात आई ना? This is x coordinate, this is y coordinate. He says find the value of x and y. Come on, do it. करके दिखाओ. Find the value of x and y. See, I can see there are a lot of questions which are coming in. What I'll do is I'll give you my email ID. Send your doubts on the email ID. Max 1 to 2 hours. I'll come back. Take my email ID. For any doubts, I'm available. It's Sandeep_4 at yahoo.co.in. Right. This is helpful, no? We've got a lot of doubts. XY. Come on. Last 15 minutes. I want the maximum energy from your side. I got this. I'll draw it again. Okay. Help me out. I know you're very good in mathematics. This is origin, yes or no? सब लोग बोले जोर से. What is this? X comma. What is the value of x? This. And what is the value of y? This is x and this is x. कैसे निकालूं? What is the value of x? How do I find out x? Do you know this r? Do you know this is omega t? So this will be r cos, and this will be r. So what is the value of x? Yes or no? And what is the value of y? Y is this? R sine r cos y. Done. Perfect. The next question. Which one, sir? Proton is released when positively charged proton. Electron is released from negative charge. When they reach the opposite, which one will have larger kinetic energy? Proton is released from the positively charged plate. Release. So if, and how would they reach, by the way? Opposite energy question. See, the issue is, I have a positive plate, I have a negative plate. Okay? I want to push a positive charge from this point to this point. Electric field direction भी होगा ना? इसका acceleration retardation होगा यहाँ पर? Yes or no? ये कह रहा नहीं? This question says this only. And if I push a negative charge from here, इसके ऊपर भी retardation होगा? Force कितनी लगती है? QE? He is asking about time? No, it's kinetic energy. We need to find out work done. What is work done? Force into displacement. Displacement तो दोनों का same है. Force कितना होगा? E is same. तो जिसका Q by M ज्यादा होगा, उसमें वर्क डन ज्यादा लगेगा. मतलब उसमें रिटार्डेशन ज्यादा लगेगी. उसकी स्पीड, yes, because retardation and not acceleration. Not understanding. It's a positive charge. Acha, okay, sorry. Acceleration. Oh, I'm so sorry. I thought the other way around. Absolutely right. This is acceleration. This is also. Oh, right. Fantastic. So what will be the acceleration? Q E by M. So जिसका Q by M ज़्यादा होगा, उसकी स्पीड ज़्यादा होगी. तो Q by M ज़्यादा किसका होता है? Q by M ज़्यादा किसका होता है? तो उसकी स्पीड. सिंपल. परफेक्ट ना? चलिए नेक्स्ट. You can take the next slide. No, not the slide. The next question. Sorry. The next question. Next 7. Now this is a magical question. Why is this a magical question? What is the difference between the question we did earlier and this? Come on, girls. Till now, in the last 36 years, there has not been a single time when a girl has scored rank 1. इतना बड़ा motivation है, such a huge motivation. है ना? थकना नहीं है. You know, in Indian cricket, there was a man called Cbse. Every time he used to make 100, he used to convert it into a double 100. Now my mama, he is a TV commentator also, and he is very close to the sports people. I asked him, Mama, is there some special reason? So my mama told me that one day he met Cbse, and he asked him, sir, why is it so that whenever you make 100, you made a double 100? You know what he said? Kehta, you never saw one thing. See, when a batsman comes to play, वो guard लेता है ना, leg stump, off stump, because he's very fresh to the pitch. But once he makes 100, he doesn't take a guard back because he knows that where the ball is coming, where am I standing. Sunil Gavaskar used to always take a guard after 100. So Mama asked him, why do you do that? He said, I'm talking to myself and I'm saying, I'm not tired. मैं तो अभी खेलने आया. What 100? I haven't made any 100. I have not spent any time here. I am coming up fresh. My body, my mind is absolutely fresh. That is what you have to understand. That you have to fight. This is going to be the biggest struggle for you. Once you think that you're trying to lose out things, make the grip tighter. Now, the difference between this and the previous question. I love this. Fantastic. This is what is so special about you girls. It is a variable magnetic field. So from a uniform magnetic field to a non-uniform magnetic field, how to graduate? ये क्वेश्चन बड़े ध्यान से सुनना, ये आपके लिए बहुत इंपॉर्टेंट है, एग्जामिनेशन में बहुत क्रूशियल रहेगा. Okay. So what is the situation? The situation is that we have B equals, बोलो जोर से, B naught x, and B is, and what is he asking? Find the maximum positive x coordinate of the particle. You want to try on your own? You can try it together. Do it, do it, do it. Outside. Queries. क्या करेंगे? अच्छा, अगर ये यूनिफॉर्म होता, आंसर माय क्वेश्चन, क्या होगा? क्या होगा? My question is, are we live again? I'll repeat my question again. If B would have been uniform, what would have been the maximum value of x? R. Because this is non-uniform, it will not be R. It will be something else. R बड़ा simple है ना? R is mv by qb. So if B was uniform, the maximum, समझे ना? भाई मैंने यहाँ से इसको रिलीज किया पार्टिकल को, ये वापस घूम के आया. What he's asking is, what is the maximum x? So maximum x क्या होगा? But this is the case when B is uniform. Now the B is, R निकालना मुश्किल हो जाएगा, क्योंकि यहां तो R simply but if I make B uniform, फिर ठीक हो जाएगा. फिर तो आंसर होगा mv by qb. Now I'll give you a trick. This is a trick. Look, see it very, very carefully. This B is a linear function of, if any function y equals fx, if x or y is a linear function of x, you can take its average value and make it constant. आप सुनो मैं ध्यान से क्या कह रहा हूं. ये मैग्नेटिक फील्ड है. परफेक्ट. ये पार्टिकल ऐसे एंटर करता है. इट एंटर्स लाइक दिस, एंड व्हाट ही इज सेइंग इज, व्हाट इज दिस? लेट मी कॉल दिस इज R. This field is non-uniform, but if I can make this field uniform by taking its average value, this will become uniform. Now, tell me, do you know how to calculate an average value of a function? Suppose I say y equals fx. Find the average of y. What do you do? It's fx dx upon dx integral. Likho. That is how you find the average of any function. Okay. What is the function here? What is the value of b? कितना है? b naught x minus a. Which region you want to make uniform? between 0 and r. So let me find the value of average value of b between 0 and, कैसे लिखेंगे बोलो, b naught x, आगे क्या लिखूं, dx अपॉन dx, yes or no. लिमिट्स क्या लूं, 0 to r, 0 to कितना हुआ ये, b naught r square by 2 r b naught r, right, you agree. आप जानते हो कितना आसान करते हैं, ये आपने क्या निकाला, b का average value. Now b has become uniform. What is radius equal to? b कितना है, r कितना है, ये आंसर है. Have you understood this? Have you understood this? Convert a non-uniform field into a uniform field by taking its average. तो वो जैसे एवरेज लिया तो b यूनिफॉर्म हो गया, डायरेक्टली यूज द फॉर्मूला फाइंड द आंसर. दैट्स अ वेरी वेरी इंपॉर्टेंट की ट्रिक. नेक्स्ट स्लाइड. How much time do we have? Try this question. It's a similar question. Let's see, can you do it? It's almost the similar question. He says it's an infinite conductor current carrying. Okay, guys? This radius is electron leaves the wire perpendicular. The maximum displacement of electron from the wire. Similar question. Why is it similar, by the way? Because B here is also non. What is B due to? U naught by 2 pi I by. That means B here is also same question. अब देखते हैं सबसे जल्दी एवरेज वैल्यू B की कौन निकालता है. You know the value of B? U naught by 2 pi I by. Okay. Limits कहां से कहां तक? Where do you measure the distance from? From the center. आप ये R है, ये दिस इज A है ना, और फिर क्या होगा, ये ऐसे आएगा, ये मेजर क्या करेंगे आप, दिस इज R. ओके, B एवरेज क्या लिखूं, U naught by 2 pi I by R. Okay, dr. Very good. And the limits will be A to A plus. Limits will be, क्या है आंसर, क्या है निकालते हैं, B naught by 2 pi I ln plus R by A upon R. What is this? B. Yes or no? हमको निकालना क्या है? What do we have to find out? The radius, the distance. What is R equal to? Do you have B? Yes, you have B. What is R equal to? Q mu naught by, okay, I ln upon R goes with, what are we left with? मैं इसको इधर ले जाऊं पूरा, इसको ले जाता हूं ln a plus r by a. This will be equal to 2 pi mv by mu naught iq. I'm sorry, because time is short, so you have to really push it harder. No issues. अब क्या करो? Exponential. So a plus r by a will be. Are you enjoying it? It's a beautiful question. इधर ले जाऊं, r कितना आ गया? बाद में लिखेंगे ना? हाँ या ना? So done with. So that means you know how to calculate B for any shape of a conductor, force in a uniform magnetic field, force in a non-uniform. Finally, we have 1 or 2 minutes left. Can we take 5 minutes more? Final topic क्या रहेगा इसका? Force on a current carrying conductor. Fast लिखो, जल्दी से लिखो. Force on a current carrying conductor. This will be your final topic. Force on a current carrying conductor. What is the formula? DF is, बोलो, I, yes or no? Ideal cross B. Okay. Now, for example, if I say this is a semicircular conductor which is carrying current I and the radius is R. This is the direction of magnetic field. What will be the direction? What will be the value of force? So, 90% students इसको याद करते हैं, they cram it. Teachers teach them as if we have to cram it. So the logic लगा. Let's just take 5 minutes. एक बार आप समझ जाओगे, लाइफ इजी हो जाएगी. थोड़ा बड़ा बना देगा. Let me draw it big. It will have two components. If I take this as theta, and I and R. Now, when you, and what is the direction of B? Direction? Yes or no? Now, as far as this is concerned, this is in the direction of B. Therefore, the force on this component will become. Agreed? I can remove this. Now you're left with this component. B is like this. Hori hai na? What will be the direction of force? Will be, निकाल लेते, इसको y ले लेते, इसको x ले लेते. Ideal is j cross j cross. What is j cross I equal to? ये force किधर लगी? Can I show a cross here? Right or wrong? अच्छा, अब इधर आते हैं. This is, it has two components. This one and ये नीचे लग रहा है, ये force कहाँ लगेगी? What will be the direction of force on this? Upwards. And this one? Finished. Over and out. Should I repeat again? And do the logic route. Logic route is much better. I'll give you a shortcut. 2 years back, there was a question which came. There is a wire, radius r, placed in a magnetic field. Initially, there was no magnetic field. Suddenly, this was switched on. What switched on? Magnetic field पहले नहीं था, अब है. What is the tension which develops inside the wire? I'll give you a shot. Interesting thought है. सुनो. You can use this in mechanics also. जैसे एक question आता है. There is a ring. About its axis, it is rotating with an angular velocity omega. Mass is m, the radius is r. What is the tension W? There is a ring. It is uniformly charged. Charge Q. You place a small charge at the center, Q. The radius is r. What is the tension W? Now understand very clearly. Let's first understand tension develop होगी. आप इस रिंग को जब रोटेट करोगे, there will be a centrifugal force outward. It cannot stretch. Internal stresses will be produced. That is what he's talking about. In this case, it's a ring. You place a charge here. The force will be repulsive. This will try to expand. Cannot expand. Stresses will be developed. In this case again, there will be forces. There should be forces which will try to push it outwards. Cannot do that. Tension develops. But in तीनों केस में एक बड़ी चीज बड़ी common है. There are two forces which are working. One, a radial force, outward radial force. Two, a tangential force. दोनों के बीच में एंगल कितना है? Whenever you have two forces operating in any question which has a circular motion, you will always have a tangential force and a radial force. Now remember this result. T, लिखो सब लोग. F by 2 pi. F is the radial force. T is the tangential force. Let's play the physics, the game of physics. Answer क्या लिखोगे इसका? What is the value of radial force? कितना होता है? Circle में radial force m r omega square. Can I say that? Upon answer. इसको लिखो. Tension. What is the value of radial force? What direction of radial force? K Q by answer. 30 seconds. इधर लिखते हैं. चलो, let's see. Can you answer this question? Tension. क्या लिखो? What is the radial force? B I L upon. ये होना चाहिए ना? L कितना है? R नहीं है. 2 pi R upon. That's the answer. परफेक्ट. अब वो सवाल जो आपके लिए चैलेंज क्वेश्चन. यू हैव माई ईमेल आईडी नाउ. आप उसको पहले करके दिखाओ. जो पहले करके दिखाएगा ही विल गेट इट. शी विल गेट प्राइज. आर यू रेडी? पक्का? हैव यू रेड कूलम्स लॉ? पक्का ना? सोच लो, बाद में मत बोलना. Charge Q1, charge Q. The distance between the charges is R. I place this charge in a dielectric medium of dielectric constant K. What is the force which Q2 exerts on Q? There are two charges given in Q2. I place them in a dielectric medium. Before the dielectric medium, कोई force होगी दोनों के बीच में? You can know. When you place them in a dielectric medium, what is the force Q2 exerts on Q? I know, 1 by. I told you, I challenged you. Search on the website, find Google, ask your friends. Next time when I meet, then I give you the answer. This is incorrect. ठीक है जी. So thank you very much. Now what I can do is we can mail these questions to the students. We have the solutions also for them. So we'll give them and then you can access them.